look out into space to experience a sense of peace and wonder. But how much do we really know about what's out there? Asteroids racing through the solar system have smashed into Earth before. What are the chances we'll get hit again? Armed with new generation technologies and daring new concepts, scientists are getting ready for the inevitable day. A decade, century, or millennia from now. The day of the asteroid. Scientists and philosophers once believed the universe worked as a precision instrument, designed by the ultimate watchmaker, God. The world around us moves in never-ending cycles, the seasons ebbing and flowing. Planets and moons circling the sun. Stars drifting across the night sky. All a testament to the perfection of creation. Scientific discoveries challenged this view. The working of natural laws in chemistry, physics, biology gradually replaced the tinkering of an intelligent designer. We've learned that the universe is shaped by violent events. Stars exploding in a fury. Galaxies tearing each other apart. Black holes emitting powerful streams of energy. Even our own peaceful world was born in violence. Astronauts walking on the lunar surface found rocks uncannily similar to those on Earth. That led to the idea that the two were formed in a planetary collision early in the history of the solar system. The craters that pock the lunar surface record a history of ongoing impacts. Earth has not been spared this pounding. The fact is that our solar system is still stocked with countless sub-planet-sized objects. Some lie in stable orbits, as in the asteroid belt between Mars and Jupiter. Others follow looping orbits that intersect with Earth's own path. Over the years, they have continued to strike our planet, often leaving marks that we can see and ponder. Of the 175 known impact sites, Meteor Crater is perhaps the best preserved. It dates back to a day some 50,000 years ago, when a nickel-iron asteroid slammed into Arizona. At 30 to 40 meters wide and a mass of 300,000 tons, it left a crater almost 200 meters deep. This is the Pengualuit crater in Quebec, created 1.3 million years ago. The impactor is thought to have unleashed the energy of over 8,000 Hiroshima-sized atomic bombs. It left a crater 3.5 kilometers wide and 400 meters deep. The Manicouagan crater, known as the Eye of Quebec, was left by a 5-kilometer wide asteroid some 214 million years ago. It may have been part of a chain of impacts that struck in what are now France, Ukraine, and North Dakota. It would have been similar to the string of fragments from the Shoemaker-Levy comet that struck Jupiter in 1994. The largest known impact crater can be found in South Africa. Known as the Vredefort crater, it's about 2 billion years old. What you see here is the inner crater. The impactor blasted out a 300-kilometer wide crater, spreading devastation across the region. It was part of a class of large impacts, capable of wreaking havoc all around the globe. Just recently, scientists discovered what appears to be a large impact basin on the east coast of Antarctica. They proposed that the impact sent shockwaves through the planet, triggering the eruption of a giant volcanic hotspot on the planet's opposing or antipodal side. That eruption is linked to the greatest mass extinction on record, including 96% of all marine species, at the end of the Permian period, about 252 million years ago. Then there's the Chicxulub crater, straddling Mexico's Yucatan Peninsula. The asteroid was at least 10 kilometers in diameter. The debris thrown into the upper atmosphere has been blamed for the extinction of all non-avian dinosaurs. In the last few decades, studies of impacts have led to a new sense of awareness that Earth remains vulnerable. It's not only the danger of a city ending up at the bottom of a crater. It's what happens when an incoming asteroid doesn't even reach the ground. Just after sunrise, February 15, 2013, residents of Chelyabinsk in southern Russia were greeted by a stunning aerial display. "23 kilometers above the town, a streaking meteor exploded with the equivalent of 500 kilotons of TNT, or 20 to 30 Hiroshima bombs. Over 1,000 people were injured, most from falling debris and flying glass. 3.5 hours later, the polar orbiting Suomi satellite began tracking the plume of dust and smoke from the explosion. Over the next 4 days, scientists tracked the plume as it spread out in high-altitude winds, forming a complete global belt. They further studied its motions with computer models in an effort that could one day help predict the atmospheric effects of incoming asteroids. The Chelyabinsk explosion was reminiscent of one of the most famous asteroid impacts in modern times. The Tunguska asteroid, simulated in these sequences, exploded over Siberia in 1908, leveling 2,000 square kilometers, including 80 million trees. What if an asteroid this size took aim at London, or New York, or any of the world's metropolitan areas? One group of scientists and celebrities believes our first line of defense is simple awareness and a sense of urgency.
Buddy, you're a boy, make a big noise, playing in the street, gonna be a big man someday. You got mud.
They are promoting Asteroid Day, June 30th, on the anniversary of Tunguska, to remind us all that the clock may well be ticking down to the next asteroid disaster. Asteroid Day has captured the imagination of many with its calls for expanded monitoring and science initiatives, spiced with slick promotion. It's also drawn criticism for its appeals to fear and for what some see as exaggerated doomsday scenarios. So how real is the threat? And is there anything we can do about it? 1998. The blockbuster movie Armageddon sent a comet on a beeline for Earth. A heroic crew travels out to meet it. Landing on its surface, they drill a hole large enough to plant a nuclear bomb. Their sacrifice is rewarded. The planet is saved. Earth doesn't get off so easy in Deep Impact, released the same year. This time, the rescue crew fails to destroy the incoming comet, blasting it instead into 2 projectiles. One hits the Atlantic Ocean. The lucky ones head for the hills. That same year, the U.S. Congress directed NASA to begin discovering and tracking near-Earth objects, those with orbits that could overlap ours, or that come within 1.3 times the distance from the Earth to the Sun. Astronomers have since identified over 13,000 objects and are adding 1,500 new ones to the list each year. That includes some 90% of all those expected to be in the kilometer class or larger. According to the data, there are no large asteroids on a collision course with Earth in the foreseeable future. In fact, our chances of being hit by one of the dinosaur killers, at least 10 kilometers across, amount to once every 100 million years. The chances of being hit by a 1-kilometer asteroid rise to once every 700,000 years. 600 and 300-meter rocks should hit every 200,000 and 70,000 years, bringing continent-scale devastation. It's every 20,000 years for 140-meter objects, and every 300 years for 40-meter objects, like the one that punched a hole in Arizona, or that blew up over Tunguska. Large asteroids can still come uncomfortably close. Take the so-called Halloween asteroid, also known as 2015 TB145. This massive object, 600 meters in diameter, flew within 500,000 kilometers of Earth, or about 1.3 times the distance from Earth to the Moon. It arrived just 3 weeks after it was discovered. The fact of the matter is that we still don't have a complete handle on the asteroid threat. As a result, NASA recently began to shift its attention to smaller objects, down to about 140 meters wide, of which perhaps only about 10% are currently known. NASA's WISE satellite has been recommissioned as NEO-WISE to search for near-Earth objects. The prolific asteroid-finding Pan-STARRS telescope in Hawaii has been upgraded. Additional projects are joining the search. ATLAS is a series of small telescopes to be deployed around the world, with large camera sensors designed to detect dangerous incoming asteroids. Looking down the road, NASA is mounting what it calls the Asteroid Grand Challenge. It will seek a variety of government, corporate, and citizen partnerships to detect, track, and stop all potentially hazardous asteroids. Planetary defense is no longer just the subject of action movies. The European Space Agency, ESA, and NASA are planning a joint project to test the idea of actually altering an asteroid's path. ESA's Asteroid Impact Mission, AIM, will target a binary asteroid system called 65803 Didymos. The spacecraft would orbit the pair to collect a range of data. That includes releasing tiny landers called CubeSats to collect specialized information. A NASA craft called DART would arrive later. This vehicle would ram into the smaller 150-meter asteroid. The impact should lead to a significant change in its orbit around its 800-meter companion. While this would not affect this pair's trajectory through the solar system, it would provide information on what it would take to alter the course of an object that might one day threaten Earth. NASA's ambitious Asteroid Redirect mission, ARM, takes a different approach. The spacecraft would slowly orbit the asteroid, scanning its surface for landing zones and for boulders commonly found on asteroid surfaces. It will then descend to the surface, deploying a pair of specialized claws that will clamp onto a targeted boulder. Rising up with rock in hand, the spacecraft will move into a position near the asteroid. The idea is to use its gravitational attraction to subtly deflect the asteroid from its Earth-crossing path. The ARM mission has a potential side benefit. The craft may be used to deliver the boulder to lunar orbit, where astronauts can get their hands on it and return samples to Earth. Plans to mitigate the threat of near-Earth asteroids coincide with rising interest in what they have to offer us. The OSIRIS-REx spacecraft is one of a range of missions proposed by governments and private ventures. It's scheduled to travel out to the asteroid 101955 Bennu and return by the year 2023 with rock and dirt samples. Scientists want to know, what can these tiny ancient worlds tell us about the early days of the solar system, 4 to 5 billion years ago? What rare minerals can future asteroid mining missions tap into? And what role can asteroids play in future human missions to explore and colonize the solar system? In this age of rapid advances in science and technology, we are gaining a firmer grasp of Earth's larger space environment. Both the resources and the threats. These same advancements are allowing us to understand the course of Earth and humanity on longer and longer timescales. Will we be ready when the inevitable arrives? A decade, a century, or a millennium from now? The day of the asteroid.